Welcome. In this video, we're going to look at one of the exciting problems under pendulum, and it is a kind of a question where a gun or a bullet is fired from a gun and it is traveling at 330 meters per second, and then it hits this block, which is in a pendulum setup. When it hits this one, the bullet gets stuck, or rather, it sticks into this very block, and then both the bullet and the block, the bullet and the block, they move together. They move together in this arc, and then the displacement, or rather, the block together with the bullet now come to this position. So now we've been given the information that is going to help us to come up with, or rather, to come up with the needed solution. So the burden of this question, it is just to find the vertical and horizontal displacements of the block from its original position. So the original position is this one. Then the final displacement is this one, but of which we know that this is the position it attains after being moved from this position to this position because of the bullet. In order for us to find this, or rather to find the vertical, which is the h, the vertical displacement, so from this position to this position, which is the vertical displacement, and then the horizontal displacement, which is from this position or this position to this position. So from this to this, or simply this one. Now, from here, what we're going to do is, we know that since this is moving with this bullet has got a mass which is 2.8 grams, and then it has got this speed. So there's an aspect of momentum. You know, momentum is actually a product of mass and velocity. So we're going to talk about the conservation of momentum. We should know that momentum, initial momentum is equal to final momentum. So from here we have the momentum of the gun. Okay, so we have m1 u1, because momentum is mv. So this one, it is the velocity, the initial velocity for the bullet, plus m2 u2, which is the momentum for the block. That must give us m1 v1 plus m2 v2. But we know that this is initially at rest, and then when the bullet hits this one, it's going to stick in this same one, and then both the block and the bullet are going to have the same speed. So this equation is going to be, so we have m1 u1 plus 0, since the initial velocity of the block is 0, which will give us m1v plus m2v, because the bullet and the block are both going to have the same speed. So from this one, we're going to have m1 u1 is equal to, so since velocity is common, we can even figure it out. We can even factor it out by factoring. Okay, we can just factor it out by putting it like this, making it the subject of a formula by just dividing. So we divide by m1 plus m2, so that this and this will go, then the velocity. So now, if we plug in the values in this equation, m1, which is 2 grams, but this one, since we need to convert to the SI unit, so we can multiply by 10 to the power negative 3 kg per gram. Then U1, we have 330 meters per second. 30 meters per second. So this is over. We have M1, so we have 2.8 plus 150. Okay, so from here to this one, a calculator, we are going to have 6.047 meters per second, which can be rounded off to 6.05 meters per second. So this is the common velocity or the common speed after this one swings in that direction. Of energy conservation, we know that energy can neither be created nor destroyed, but can only be converted from one form to another. So from this one, since this is moving, the energy that is possessed by a moving object is kinetic energy. So kinetic energy. Now, when it comes to this point where it is okay at this maximum displacement, what it is going to the form of energy it is going to attain is the gravitational potential energy. So gravitational potential energy. So from this one, we can just plug in the formula now. So we have half mv squared is equal to mgh. But from this point, we know that the mass and the mass, these are common. So we can even do this, even here, we can do this so that we just remain with v squared over 2 is equal to gh. But we want to find h, which is the vertical displacement. So we can divide by g, and also here by g, so that this and this will go, and then we're going to have h is equal to v squared over 2g. So our h will be, the v we have 6.05, okay, so meters per second squared over 2 times, so this one, the g is actually the acceleration due to gravity, okay, which is simply 9.8 meters per second squared. So this one, when we punch it on a calculator, what we're going to have is 1.8. 1.8 meters. So this is the vertical displacement of the block. And then from this one, we're going to proceed to find the horizontal displacement. But we know that the total length from this point to this point is 2.8. So y plus h, this one from here to here plus from here to here. So we have y plus h must give us 2.8. So from here we can find y is equal to 2.8 minus h. So 2.8 minus 1.8. What we're going to have is 1. So simply 1 meter. So here we have 1 meter, and then here we have 2.8. Here we have x. So now, from Pythagoras theorem, we know that this one, which is, let us call this as okay, this is which is the hypotenuse. We know that y squared, or simply x squared, plus y squared must be equal to 2.8 squared. So from this point, what we're going to do is, we know that y is 1 meter. So we have x squared plus 1 squared is equal to 2.8 squared. So we can take this to this. So we have x squared is equal to 2.8 squared minus 1 squared. So from this point, we are going to have x squared is equal to, so 2.8 squared minus 1 squared, we are going to have 6.84. So from this, in order for us to find the value of x, we just need to introduce the square root here and also here, so that our x will be 2 point. So when we figure it out, when we punch on a calculator, we are going to have 2.6 after rounding off. So this is it. This is meters. Now, from here, we know that the vertical displacement is this one from this one to this one. Then the horizontal displacement is from this point to this point. And so the needed solutions are vertical displacement, which is h. So h is equal to 1.8 meters, and the horizontal, which is x, this is 2.6 meters. So this, or these are the solutions to this question.